All right, we're back with Thomas Taylor's dissertation on Aristotle's philosophy, and we're looking at why there can only be one world. The basic argument is that the basic bodies are the necessary ones, and they're defined by their natural motions. The natural motion of Earth is towards the center. If there were more than one world, as in more than one planet, basically, then Earth would move in contrary directions. Simplicius kind of picked up on the idea that perhaps, like being further from the center, that force or natural tendency of Earth towards the center would be weaker. And you could simply combine that with the idea that Aristotle contemplates but doesn't take seriously, that there are multiple centers, and you would have something close to a universal theory of gravitation. But Simplicius doesn't quite get there, so we'll keep on going with Aristotle. We did not read footnote 4 here. Let me go back in the text slightly. For all of them are similarly without any specific difference from each other, but any one differs from any other in number. But I say this because the parts which are here and the parts in another world subsist similarly with respect to each other. Hence the part which is assumed here will have no difference when compared with some one of the parts which are in another and in the same world, but will subsist similarly with reference to all, for they will not at all differ from each other in form. And there's footnote 4. So this is Simplicius. Having shown that each of the simple bodies has necessarily a certain natural motion, he consequently shows that of all those bodies which are of the same species and of individuals, there is a natural motion to a place numerically one. For instance, to this middle in this world, and to this extremity, or to the middle and extremities in another world. And what really hasn't been demonstrated is that it must be numerically one instead of specifically one, because they're looking at the possibility that they go towards specifically the middle, but then the middles are multiple in number, as in each planet has its own middle, and all Earth moves towards a middle, but not towards the one specific middle that we find here. And he's saying, he's just asserting that all natural motion is to a place numerically one, and maybe we'll get an argument for that. For if heavy things naturally tend to the middle, they either tend to a middle which is numerically one, or to a middle which is specifically one but numerically different. It may perhaps be said that as with respect to things heavy and light, each is one in species but many in number, so the middle, to which heavy things, and the extremity to which light things tend, are each of them one in species but many in number. And that some things tend to this extremity, but others to others, which are specifically the same with this, but numerically different from each other, in the same manner as the bodies which tend to them. Thus there will be many worlds, the same in species with each other, but different in number, and separated from each other. So that's that possibility. If therefore, says Aristotle, this should be said by anyone, we must reply to him, that with respect to that which ranks as a particular, this particular will not consist of such and such parts, but that of different parts. For a particular clod of earth in another world is not specifically different from, but similar to a clod in this. For all things according to species are similarly without difference with respect to each other. Okay. Though one is different in number from another, not only things here with respect to each other, and in a similar manner things which are there, but also things which are here with reference to things which are there. and a part of earth or fire, which is assumed here, has no difference with respect to the remaining part of earth that is here, it being specifically the same. In a similar manner, neither has it any difference with respect to the parts in another world. As therefore, the parts of earth in this world, being the same in species but differing in number alone, tend to a middle which is one in number, in a similar manner, the parts of earth in another world, which are of the same species with these and differ from them in number, will tend to this very same middle. Okay, which is kind of a weak argument. It's inductive. So all the parts of Earth which we observe move towards this particular middle. Therefore, they can't just move generically to middles. But of course, that's kind of a sampling bias in reality. For why, since all the parts of this Earth are the same in species, but differ in number, do these naturally tend to this middle alone, because it's the closest, and not to another? But the parts of another Earth, which are specifically the same with the parts of this, but only differ in number from each other, and from the parts of this Earth, why do they no longer tend to this middle, but to another of the same species with this? Proximity, which Simplicity has already mentioned as a possible factor. For if the difference, according to number of things which are moved, is the cause of places differing in number, it will be requisite that each of the heavy bodies that are here, which are alone numerically different, should separately tend to another and another middle. Okay, so they either tend towards something because of their specific differences or their numerical differences, and so each body tends randomly to its own unique middle corresponding to its number. Or again, you could just posit that things move towards the middle which is closest, which is so wild that Simplicius did actually have all the necessary premises to get there, but then he doesn't. Aristotle. So that it is necessary either to subvert these hypotheses or to admit that there is one middle and one extremity. But this being the case, it is necessary that there should be only one heaven and not many, for these same arguments and the same necessities. That there is, however, a certain place to which earth and fire are naturally adapted to tend is evident from other motions. For in short, that which is moved is changed from something into something, and the terms are from which and to which, but they differ in species. All mutation, however, is finite. Thus, that which is restored to health proceeds from disease to health, and that which is increased proceeds from smallness to magnitude. The like, therefore, takes place in that which is moved, for this proceeds from one place to another. Hence, it is necessary that the boundary from which and the boundary to which a thing is naturally adapted to be moved should be specifically different. Thus, that which is restored to health does not proceed anywhere casually, nor where the mover pleases. Fire and earth, therefore, are not moved to infinity, but to opposite places. Okay, so motion is a kind of change. All change comes from something to something, and those things must be different. And they can't then just be a relative difference, which is the other option, that something moves from what is relatively central to what is relatively distal or something. Instead, it's a specific difference that needs to account for that from which to which is specious, but you can kind of see what he's getting at anyway. And let me just put in the chat, let me know if there are Any issues with the stream, please? Okay. And for upward and downward are opposed according to place, so that these are the boundaries of lation, or movement in a right line. Okay, so footnote 5 here. Having shown that there is but one world, from there being but one middle, Simplicius, and one extremity, to the former of which heavy things tend, and to the latter light, he now proposes to show that there is something to which earth and fire naturally tend. For this is not being demonstrated, neither according to this argument will it be demonstrated that there is a middle and an extremity, nor that the world is one, but he demonstrates this by showing that the upward and the downward are the boundaries of motion. And he demonstrates this by showing that the motions of them are finite and are not produced to infinity. This also he demonstrates from all mutation being finite. This because it is from the definite. This again because it is from the opposite to the opposite. And lastly, this because it is from that which is different in species to that which is different. Right, and that last is perhaps, is it always true? I mean, motion moving between opposite ends of a continuum is all motion from one thing in species to another thing in species. It seems like that's a premise that he wants us to buy, but that itself is not really being proved. And such is the analysis of the reasoning. But the composition of it is as follows. Things which are locally moved change from something into something. For while they remain in the same thing, they will not be changed. But that the things from which mutation is effected and to which it tends are different in species and opposite, he shows in the first book of his Physics. For that the intermediate motion proceeding in continuity is produced as from a contrary to a contrary, he first assumes from that which is moved being moved from a different to a different form, since motion from the same to the same form will not be mutation. For that which is changed departs from that which it changes. But if it is from the opposite to the opposite, and from the definite to the definite, for opposites are definite, it is evident that they are contraries, as being most distant under the same genus. But the most distant is definite, and if these are definite, it is evident that they are boundaries, and the motion and mutation produced according to them are on this account also finite. All mutation, therefore, is finite. He also appears to remind us of that demonstration which says, okay, so once again, he didn't show that all motion is from something that is one in species to another in species. Opposite ends of a continuum, that it's between opposites, that it's finite, that's all fine. But he didn't actually show that it has to be from one species to another. All mutation, therefore, is finite. He appears also to remind us of that demonstration which says it is impossible for anything to have been moved to anything and not to be moved to it from the beginning, because it is impossible for anything which is moved to come into contact with that which is infinitely distant. And he shows through induction that mutation is effected to finite things. This he evinces in things changed according to aliation, or a change in quality, and according to increase and diminution, because the term from which and the term to which differ in species and are bounded and finite. So the from which to which, those are differing in species in some sense, and so anything that falls under the category of from and what falls under the category of to have to differ in species. But it could be a relative could be an accidental rather than essential property. Essential properties determine the species of a thing, but accidental properties, you can move from one accidental property to another accidental property and not change species. Motion, according to aliation, or change in quality, doesn't involve a change in species of the thing, but I guess even then it's like from the small to the large. Well, okay, we'll keep going. I guess the move is like even relative motion is going to involve some kind of specific difference between the from and the to, like there and here, far and near. Those are specifically different, although they're relatives. And the move is like taking the fact that there are opposites and specific differences to saying, and therefore the numerical identity of the center and the periphery of the universe is one. And there's, yeah, just kind of a gap in reasoning to get there. But alright. Bounded and finite. For natural increase and diminution are bounded, and universally mutation according to place, and that which is beyond is now contrary to nature. But as in things which change according to quantity and quality, the mutation is from one boundary to another, and the terms in which and to which are specifically different are contraries, definite, and boundaries. Thus also in things which change according to place, the local differences of the bodies, which are naturally moved, viz. The upward and the downward, being specifically separated, are contraries, definite, and boundaries. These, therefore, are natural to fire and earth. They could be specifically separated in terms of the relative or the accidental properties of what is from and what is to. So accidentally, something could be distant. Accidentally, something could be central relative to something else. So there's still a specific difference even when it's not an essential difference of that thing. And he's conflating specific differences of accidental and relative properties to specific differences of essential properties, and then not recognizing that. Being specifically separated are contraries, definite, and boundaries. These, therefore, are natural to fire and earth. Hence, there is something to which earth and fire naturally tend, viz., the upward and the downward. But these are not casual situations, nor where the mover pleases. For he who is restored to health, if in short he is restored to health, though he by whom he is restored should not be willing, changes into health, or he would not be restored to it. So change has to be to somewhere definite, but health too is not like the same numerically in all cases. You can move to health. That doesn't mean that health is one place that all things move to. Health is relative to each thing that moves towards it, and yet it's specifically, definitely one, and is the contrary of illness and everything, and constitutes a fixed, limited boundary that we can move towards. So anyway, that example kind of undercuts the point. Back to Aristotle. For a circular motion also has in a certain respect the motions which are distant by the diameter opposites, but to the whole motion nothing is contrary. So that from hence also motion after a certain manner is to opposites and things finite. Okay, so footnote 6, Simplicius. Aristotle, having said that mutation according to place is from an opposite to an opposite, viz., is according to a right line, for this is properly lation, adds that the motion in a circle also, though it is not simply lation, but circulation. Ah, okay. Yeah, we had that term lation. I never put it together. Circulation and then just lation. That's kind of neat. Though it is not simply lation but circulation, yet has in a certain respect opposites according to the diameter. But if it should be doubted why Aristotle, having before demonstrated through many arguments that there is not any lation contrary to the lation in a circle, and having also shown that the motions which are opposite to each other according to the diameter are not opposed as opposites in the circle, but as moved according to the diameter, now, as if he had altered his opinion, says that a circular motion also has in a certain respect the motions which are distant by the diameter opposite. Should this be doubted in the first place, let him who makes the doubt attend to the accuracy of Aristotle. So it looks like he's waffling, where before he said there's no motion contrary to circular motion. Now he's saying, well, in a certain respect, the motions within a circle are still according to opposites. Simplicius, for he does not simply say that a circular motion has opposite motions, but that it has in a certain respect opposites, since the motions of bodies to contrary places are properly said to be opposed to each other. Okay. So we have sensu stricto. No, it's senso strictu. Dang it. I forget this like every time, which one's the O and which one's the U. Sensu stricto. Yeah, it is. Okay. Sensu stricto. In the strict sense, circles do not have opposite motions, but in a wider sense, they do. Since the motions of bodies to contrary places are properly said to be opposed to each other, and contraries are those which are most distant from each other. But things which are moved in a circle are neither moved to the place according to the diameter as to the end, but they are moved from the same to the same, nor is the motion according to the diameter the most distant to that which is moved in a circle, for most is that which does not receive an addition. But after the distance according to the diameter, the motion and the distance still receive an addition, till the restitution to the same point. For the distance from any given point continually increases till the restitution to that point. I mean, sort of, like once it gets closer to the original point in its circulation, you could say the distance traveled is larger, but that could increase infinitely. Like the actual straight line distance from one point to another point on a circle is of course the diameter. But Aristotle also having very accurately said that a circular motion has in a certain respect the motions which are distant by the diameter opposites, adds, but to the whole motion nothing is contrary, for the very color itself of opposition, which there appears to be, is in the parts of the motion in a circle, not in the whole. And before, when he argued this, and still now, they've not talked about clockwise versus counterclockwise motions in a circle, but and in the parts, indeed, it has not properly a subsistence, since motions which are properly opposite are interrupted by rest. So even in the parts, there is no fundamental opposition involved in the motion of a circle. Nothing is opposite to it, even in the parts, strictly speaking, because when there's a motion between contraries, there's a point of rest in the change of direction. And when things which are moved naturally with opposite motions become one and the same, the one is moved contrary, but the other according to nature. But things moved in a circle neither stand still when they arrive at the diameter, for they are not moved according to it, nor are they moved in one of the semicircles according, but in the other contrary to nature. So, the motion is always according to nature. There is no rest that interrupts motion between opposites. In a wider sense, there is opposition even involved in the motion of a circle. But once again, we've neglected clockwise versus counterclockwise. So it's kind of funny. Do you remember Karnik why he found it necessary to try to prove that there's no motion contrary to circular motion? Was that, oh, to the eternity of the heavenly bodies, or perpetuity of them, indestructibility, right?
Sure. Sure. I think
I
that's
think,
it.
yeah. So, because like right line motion move back and forth between contraries, and I forget the precise argument for why motion between contraries invites a tendency towards degradation, but it did. But in any case, things that admit of contrary motions are able to like come into being and go out of being, I guess, because those are opposites. That's a contrary motion. So the kind of thing that can pass out of being is the kind of thing that admits of contrary motions. Whereas circular motion has no strict opposite to it, but once again, it kind of does, because clockwise, counterclockwise, and he just neglects that. Okay. It is therefore necessary, Aristotle. It is necessary, therefore, that there should be some end, and that they should not be moved to infinity. Footnote 7. Simplicius. Having shown that the motion in a circle, and especially that the motion in a right line, for his argument required these in order to show that there is one middle and one extremity, are not produced to infinity, but terminate in opposites, things definite and finite, and having added that the motion in a circle has in a certain respect opposites, he now concludes that it is necessary that there should be a certain end, and that bodies which are moved should not be moved to infinity. But if this be the case, there is something to which earth and something to which fire are naturally adapted to tend. And if this be admitted, okay, so that's an interesting point. If motion is between contraries, contraries are extremities, extremities are finite, then motion is to the finite, and infinite motion is impossible. And mm, interesting. I guess like if we have a infinite motion is possible because motion is always between contraries. I suppose I guess the step that might be challenged is that the contraries are necessarily extremities of a continuum, because perhaps motion is between like corresponding points. Like imagine a number line, you have negative and positive. You move from 5 to negative 5, and that oscillation is perpetual. Motion being there between opposites, but there is hypothetically a possible continuation on the same spectrum. I don't think he justifies that motion between contraries is always between the extremities. I mean, that's by definition. The definition of a contrary is what is most extreme on a spectrum. The idea that all motion involves motion between contraries, maybe there's some truth to it at interpreted in a certain way, but it's not clear why there can't be oscillation between points on a spectrum that aren't the extremities of that spectrum. And then you would have motion between opposites, but not necessarily between contraries. So that step, requiring that motion be between contraries. I mean, interpreted like metaphysically in the extreme, if all things proceed abide, and revert from the one to the lowest point of being potentially, then all motion in like the widest possible sense is between contraries, and all motion is finite because the cycle is necessitated, like metaphysically, the proceeding, abiding, reverting of all things is metaphysically necessary, and therefore, like ultimately, Aristotle's point here holds. But the idea of infinite motion, you couldn't have an actual infinite motion, but maybe you could maintain a potentially infinite motion in that it could always be increased arbitrarily, but the motion would have to necessarily ultimately terminate at one end of like this metaphysical spectrum. Anyway, just thinking about that point, it's interesting. Okay, but if this be the case, there is something to which earth and something to which fire are naturally adapted to tend, and if this be admitted, there is one middle and one extremity. There is something which they are naturally adapted to tend towards, because they're not moved to infinity, but they could again move towards the spectrum being judged on relative position rather than absolute position. And he doesn't really exclude the position being defined relatively, because you can still have specific differences, still finite, still all his other premises about the motion, but not numerically one. He just kind of throws the numerical unity, numerical oneness of the end of motion in. Again, I think because he's conflating between the from which to which requiring a specific difference, and then the from which to which requiring a specific difference in the essence, in the substance of a thing. Okay. Something to which fire are naturally adapted to tend, and if this be admitted, there is one middle and one extremity. The motion in a circle also, though it should not be interrupted, but should continue to infinity, would not be such an infinite as that of the motion in a right line, in which the body that is moved is always in another and another place. But the motion in a circle is always in the end, as it is also always in the beginning. Okay, so infinite motion in a circle is no problem because it's not always in another and another place. So the limits, the end and the beginning, the from which and the to which, are always present, never violated. What I was getting at before with the right line motion, like you could have the limits be an asymptote where you could continually increase towards it. It is a real definite limit, but there's always potentially an increase towards it available. Of course, Aristotle didn't have the concept of the asymptote. So, okay. It is necessary, therefore, that there should be some end and that they should not be moved to infinity. Aristotle continuing, but this is an argument that bodies are not moved to infinity, that earth is more swiftly moved as it approaches nearer to the middle, and fire as it approaches nearer to the upward region. Okay, so he kind of recognizes that as you get closer to the middle, the motion is more forceful. Like Aristotle himself had all the necessary premises to reach the conclusion that things tend towards the middle that is closest. But okay. If, however, the upward region were infinite, swiftness also would be infinite, and if swiftness, gravity also, and levity would be infinite. Okay. And the conclusion that fire moves the faster the higher up it moves, that's like just a false premise, of course. I don't know why he believes that. I mean, you can kind of see. He assumes fire is going to be the opposite of Earth and the motion of Earth. There's acceleration towards the center, So you see that as things fall, they move faster and faster. That's easy to observe. And so as fire rises, it must move faster and faster towards its end. But no. For as that which tends downward, differing in celerity, is swift through gravity, thus also, if the addition of this were infinite, the addition likewise of swiftness would be infinite. Okay. Footnote 8, and we'll probably stop there and then begin with the top of this page. Neither. Wait. Okay. My scroll bars. Yeah, we'll start 240 next time. But footnote 8 for now. Simplicius. That the upward and downward are definite, and that bodies which are moved in a right line are not moved to infinity, Aristotle adduces this as an argument that earth, by how much nearer it becomes to the middle, is moved by so much the swifter, and that fire is moved by so much the swifter, by how much the nearer it approaches to the upward region. For if the upward and downward were not definite, but the distance was infinite, and the end was not determined, there would always be an addition to the velocity to infinity. The idea that fire just tends, like you can see that fire rises, but it doesn't just continue to rise. So like exactly where this idea came, which is like ubiquitous among ancient authors, that fire just rises all the way. Like you could see that that's not the case by like being very high up above a fire and noticing that eventually the heat just dissipates. It doesn't infinitely continue to the sky. But they seem to think that it would, and that it would accelerate in its motion as it moved up. On what basis? We're not sure. And the end was not determined, there would always be an addition to the velocity to infinity. If therefore velocity is produced on account of natural tendencies, and some things are moved upward on account of having more levity, but others downward in consequence of having more gravity, it is evident that gravity and levity existing inwardly as natural powers will receive an infinite addition. Okay, so gravity and levity are determined relative to the proximity to center or extremity. And so if those were infinite, then the gravity and the levity would be infinite, and the swiftness would be infinite. It is not, however, necessary, says Alexander, to fancy, if this be the case, that the bodies which are moved will be infinite, but that they will receive an addition to infinity. For it is impossible that the proper power of a finite body, which does not always receive an addition, should increase to infinity. Simplicius farther observes that Aristotle omits to add, partly because it is easy to be understood, that if heavy bodies, when they become near to that place which is downward, and light bodies, when they become near to that which is upward, are moved more swiftly, it is evident that these places are natural to them, for they would be moved in a contrary manner to the opposites of these. That bodies, therefore, are moved more swiftly when they are nearer to their proper places appears to be universally admitted. But a different cause of this is assigned by different ancient writers. For Aristotle thought that the nearer they approach to their proper wholenesses, the more they become corroborated by them, and receive a more perfect form. For the addition of gravity causes earth to tend more swiftly to the middle. But Hipparchus, in his treatise inscribed Concerning Things Which Tend Downwards Through Gravity, says that when earth is thrown upward, the power which throws it, as long as it is superior to the power of the earth which is thrown, is the cause of its motion upward. And by how much the more its force is superior, by so much the more swiftly is the earth moved upward. But when this force is diminished in the first place, it is no longer moved upward with a similar velocity, and at length is moved downward, this being its proper tendency, and the power in a certain respect remaining, which threw it upward. This power, however, becoming weaker, that which is moved downward is always moved with a greater velocity and with the greatest velocity when the power that threw it entirely fails. So here, it's not, Hipparchus says it's not that gravity increases as you move closer to the center. It's that that is constant, and instead, the violent motion which allowed the Earth to deviate from its proper place in the first place, that diminishes through time, which is nearer to the truth. He also assigns, and Hipparchus was the one who invented the heliocentric model, I think. No, his he discovered the precession of the equinoxes, supposedly. Anyway, competent geometer, astronomer. Okay. Let me just read a little bit more about Hipparchus. Hipparchus is considered the greatest ancient astronomical observer and by some the greatest overall astronomer of antiquity. He was the first whose quantitative and accurate models for the motion of the sun and the moon survive. For this, he certainly made use of the observations and perhaps the mathematical techniques accumulated over the centuries by Babylonians, blah blah. And he developed trigonometry, constructed trigonomic tables, and he solved several problems in spherical trigonometry. His prediction of solar eclipses was more accurate. Okay, so not necessarily the inventor of the heliocentric theory. Who was that? Who invented the heliocentric theory? It was a successor to Plato in the academy. Not a scholarch, but just a student there. Who invented heliocentric theory? Well, Copernicus in recent times, but like ancient Greece.
Aristarchus?
Aristarchus of Samos.
Right.
Yeah. All right. Okay. So we have this theory by Hipparchus, though, that the violent motion which led to the deviation of Earth fails over time. The natural motion is constant, whereas Aristotle says the natural motion increases in force as it approaches its proper place. He, being Hipparchus, also assigns the same cause of things which are moved from the upward to the downward, for in these also the power which causes them to fall remains for a certain time, and the power of the falling body being contrary to this is the cause why the falling body is moved more slowly at the beginning. Alexander, however, well observes that in bodies which either are moved from or remain in a place contrary to nature, what Hipparchus says is true. But in those things which after they are generated tend to a place adapted to them according to their own proper nature, can no longer be admitted. Okay, so when Earth is spontaneously generated far away from the center, like I guess a meteor. I haven't read their ancient books. Multiple ancient authors wrote on meteors, so I wonder what the theory is there. But okay. Others again, and those not a few, Simplicius adds, say that the reason why bodies which are moved downward are moved with greater velocity by how much the nearer they approach to the downward place is because bodies, the higher they are, have a greater quantity of air under them, which is diminished in proportion as they draw nearer to the surface of the earth. Well, that's interesting. air naturally tends upward, so that provides a contravailing force. Hence, they say that the more heavy bodies are moved more swiftly because they more easily divide the air beneath them, and that by how much the greater the quantity of air is which is under them, by so much the lighter they will seem, just as it happens to bodies which are moved downward in water. Okay, so this is others and not a few, several ancient authors, which we don't have names for, held that opinion. In a similar manner, also a greater quantity of fire will more rapidly tend upward because it more easily divides the air which is above it. And by how much greater the quantity of the air above is, by so much the slower will that be moved which passes through it. For though air is not naturally adapted to subsist similar to water, yet at the same time, being a body, it impedes the motion of the bodies moved through it. But if this be true, the increase in the velocity of falling bodies will not arise from the addition of gravity, as Aristotle says, but from the removal of the impediment. So interesting, Simplicius sort of cedes that Aristotle might be wrong. They're dissenting opinions. What Aristotle says in that previous section, Simplicius doesn't defend outright in his notes, although maybe in his complete commentary there is a defense. Taylor doesn't decide to share that if that's the case. So, all right. Okay, that's it then. Um, any last comments on the reading today?
No.
Yep. Kind of more of the same, but getting into Aristotle's mindset and why he thinks physics is the way it is. Interesting stuff. We're on page 240. So we'll pick up here. Hopefully, should be tomorrow. Sorry about last week. I had to cancel the groups. I knew that I was going to have to. I just didn't inform people in time. I had to play at church. So, but not this week. So, see you guys then. Take care.
Thanks. Bye bye.